A quadratic function is a polynomial function of degree 2. Its general form is function of x equal to ax squared plus bx plus c, where a, b, c are real numbers. A is not equal to 0. The highest power of x is 2, which make it quadratic function. The graph of a quadratic function is a parabola. If a is greater than 0, the parabola open upwards like this. If a is less than 0, the parabola opens downward like this. The vertex point is the turning point of the parabola. And for us to determine the x coordinate of the vertex point is x equal to minus b over 2a. The vertex form of quadratic function is function of x equal to a x minus h squared plus k. And the factor form, when roots are known, is function of x equal to a x minus r1 x minus r2. The domain of quadratic function is always negative infinity to positive infinity, and the range depends on the directions of the parabola. If a is greater than 0, our range will be square bracket k positive infinity, where k represents the y coordinate of the vertex point, and the vertex point is normally written as h, k. And if a is less than 0, the range is negative infinity, k square bracket. This square bracket means that k is inclusive. Let us consider this example. Function of x equal to minus x squared plus 4x plus 1. And standard form of quadratic function is function of x equal to ax squared plus bx plus c. And if we compare these two equations together, you see that our a is minus 1, our b is 4, and our c is 1. And let us find the x coordinate of the vertex point. Our x equal to, the formula for finding is minus b over 2a. Let us substitute our value, minus 4 divided by 2 multiplied by minus 1. The answer is going to be plus 2. And let us find the y coordinate of the vertex point by substituting 2 into this equation. That means function of 2 equal to minus bracket 2 square plus 4 times 2 plus 1. And if we simplify everything, our value is 5. That means the vertex point is 2, 5. And notice that a is less than 0. That means that the graph of our quadratic function open downward like this, and the range is going to be negative infinity, 5 square bracket. And the domain of quadratic function is always from negative infinity to positive infinity. We want to find the domain and the range of this given quadratic function. And the domain of quadratic function is always from negative infinity to positive infinity. That means D, which represent domain, full colon, open bracket, negative infinity, positive infinity, close bracket. This is the domain of the given function. Now let us find the range. But before we find the range of this given quadratic function, let us first write it in standard form. Function of x equal to x squared plus 0x plus negative 5. Now, and standard form of quadratic equation can also be written as follows. Function of x equal to ax squared plus bx plus c. Now, if we compare these two equations together, the coefficient of x squared here is 1. So our a is 1. Our b also is 0. Whereas our c is minus 5. C equal to minus 5. The x coordinate of the vertex of this quadratic function can be calculated by using this formula. X equal to minus b over 2a. Now let us substitute the value of our b and our a into this equation. We are going to have minus 0 over 2 multiplied by 1, which is equal to 0. That means the x coordinate of the vertex is 0. For us to determine the y coordinate, we have to substitute this 0 into this equation. So function of 0 equal to 0 square minus 5. That means function of 0 equal to minus 5. This is the y coordinate of the vertex of the quadratic function. The vertex can be written as follows. V open bracket h, k, close bracket. And let us substitute our value into it. Our h here represent the x coordinate, which is 0, and our k represent the y coordinate, which is minus 5. And for us to determine the range of a quadratic function, it is actually influenced by the value of a. If a is greater than 0, it means that the graph of our quadratic function open upward like this, and the range will now be square bracket k, infinity, close bracket. And if a is less than 0, it means that the graph of our quadratic function open downward like this, and the range will now be open bracket negative infinity, k, close bracket. But in this case, the value of a is greater than 0. That means that we are going to use this format. So our range square bracket minus 5 comma infinity close bracket. And this square bracket simply means that negative 5 is inclusive. Find the domain and the range of this quadratic function. And this quadratic function, it is in factor form. So the first thing that we have to do is to find the roots of the equation. Now for us to find the root of the equation, we are going to equate this to a 0. Bracket x plus 1 close bracket bracket x minus 5 close bracket equal to 0. That means x plus 1 equal to 0 or x minus 5 equal to 0. Let us put x sub 1 here. That means x sub 1 equal to minus 1 or x sub 2 equal to 5. Now the next thing that we have to do is to calculate the x coordinates of the vertex of the quadratic function. So the formula for calculating the x coordinates is x equal to x1 plus x2 divided by 2. Let us substitute the value of x1 and x2 into this equation. So minus 1 plus 5 over 2. The answer is 2. Now the next thing to do is to calculate the value of the y coordinate of the vertex of the quadratic function, and we can do that by substituting 2 into this quadratic function. That means f of 2 equal to bracket 2 plus 1 close bracket open bracket 2 minus 5 close bracket, which is equal to 3 multiplied by minus 3. The answer is going to be minus 9. That means our y coordinate of the vertex is minus 9. And the vertex is normally written in this format: h comma k. Here our h is 2 and our k is minus 9. That means our vertex is going to be 2 comma minus 9. Since this is a quadratic function and the domain of the quadratic function is always from negative infinity to positive infinity, so our domain will be negative infinity comma positive infinity. So the next thing that we have to do is to calculate our range. But I want you to understand that if we multiply this factors form, the coefficient of our x square is going to be positive. That means that our a is greater than a 0 and the graph is going to open upward like this. If the graph is open upward like this, it means that our range must be in this format: square bracket k comma infinity, and our k here is negative 9, so that the range of the given quadratic function is square bracket negative 9 comma infinity close bracket. This square bracket simply means that our minus 9 is inclusive. For the following, determine the domain and the range of the quadratic function. These are the given quadratic function. Let us start with number 1, which is a. Function of x equal to open parenthesis x minus 2 close parenthesis square plus 2. The standard form of a quadratic function in a vertex form can be written as follows: function of x equal to a open parenthesis x minus h close parenthesis square plus k. Now if we compare these two equations together, we will see that our value of a is 1 because we can write 1 here. A equal to 1 and our h will be 2. H equal to 2, and our k here will also be 2. K equal to 2. And the domain of any quadratic function is always from negative infinity to positive infinity. So our domain, open parenthesis, negative infinity, positive infinity, close parenthesis. Now we want to determine the range, but I want you to understand that if our a is greater than 0, it means that the graph of our quadratic function open upward like this, and our vertex point is at this point. So we need to determine the vertex point of this quadratic function, and our vertex point is normally written as open parenthesis h comma k, and our h is 2 and our k is 2. So our vertex, open parenthesis, 2 comma 2 close parenthesis. Whenever our a is greater than 0, our range is in this format: r square bracket k comma positive infinity and close parenthesis. This square bracket simply means that k is inclusive and our k is 2. Our range will now be square bracket 2 comma positive infinity close parenthesis. Now our domain is this and our range is this. Now let us solve for the second question, which is question B. Function of x equal to -2 open parenthesis x plus 3 close parenthesis square minus 6. The given function can be written as follows: function of x equal to -2 open parenthesis x minus open parenthesis -3 close parenthesis everything square minus 6. Standard form of a quadratic function in a vertex form can be written as follows: function of x equal to a open parenthesis x minus h close parenthesis everything square plus k. Now if we compare these two equations together, we will see that our a equal to -2, our h, this h is the same thing as -3. That means h equal to -3 and our k equal to -6. And I have said earlier that whenever we are dealing with quadratic function, the domain is always from negative infinity to positive infinity. So our domain is open parenthesis negative infinity comma positive infinity close parenthesis. But our range, we need to calculate our range now. But I want you to notice that the value of a is -2. It means that a is less than 0. And whenever a is less than 0, it means that the graph of the quadratic function open downward like this. So our vertex is at this point. Now, whenever our graph open downward like this, the range is in this format: r colon open parenthesis negative infinity comma k and square bracket. This square bracket means that k is inclusive our r, which is range, open parenthesis, negative infinity, comma, and the value of our k is minus 6 square bracket, and this square bracket simply means that our negative 6 is inclusive.